Good afternoon. My name is Ethan Spessert. I'm an aerospace engineering major at Georgia Tech, second year here, and I'll be going over the lab we conducted of the combustion in a Reiki tube. Background. Reiki tubes are combustion tubes specifically designed to have oscillating flow from the heat source that will create a resonance in the tube. Reiki tubes have open ends to let heat escape and create sinusoidal pressure oscillations. Resonance creates a sustained sound. When the resonance goes away, it will sound more pulsated or won't be audible. Combustion intensity is increased because of a better mixing of fuel and air in Reiki tubes as opposed to steady flow tubes. Measurements. Attached to the Reiki tube were 3 pressure transducers, one at the middle of the tube and the other 2 on either side of the middle, splitting the distance to the ends of the tube. These pressure transducers were in the form of piezoelectric transducers. They measure it in millivolts, which we then convert later on to decibels. A photomultiplier measured the light emitted by the flame by only observing wavelengths between 305 to 315 nanometers. This is the range that the light from our flame will be in. We used an oscilloscope to measure the output waveforms of the pressure fluctuations. The flow of gas was measured using a rotometer. Procedure. The flame was ignited at the 6-inch mark and visually observed. We then moved it down to the 0-inch position. We took measurements at the 0-inch mark and again with a back valve open to allow pressure to escape. Then we raised the heat source until the resonance stopped at 5.2 inches. Then we lowered the heat source until the pulses resumed at 3.7 inches. At this point, the experiment was concluded and we turned off the burner. Results. The resonance frequency, which you can see on the top right, was calculated to be 95.3177. This was based on standard air, temperature, and pressure. Obviously, in our experiment, we did not have STP, and thus the resonance frequency which we actually observed was not 95. Our data had multiple errors in the outlying numbers for the peak frequency. Numbers less than 50 and over 120 were considered errors, due to those being decibel values that wouldn't be relevant. The peak frequency found at the lower transducer, the one closest to the heat source, in test 1 closely matches the calculated resonance frequency. We can claim then that the Reiki tube was in resonance during that test at 98 Hz. Due to the errors in the data on the previous slide, this data tells us more about when resonance was present. Stronger resonance is indicated by higher pressures. Thus, in the first test at 0 inches, the resonance was present and strongest. In the second test at 2 inches, there was still pulsations, but the resonance was not fully present. The height of test 3 was determined by when the pulsations would entirely cease, so clearly there is no resonance here, and that is supported with very low pressure values. Analysis. In this graph of pressure versus frequency, you can see that in P1, P2, and P3, the pressure oscillates between 80 and 100, averaging out around 90. What happens as the heat source moves upwards? As it moves upwards, it moves away from the node where resonance frequency is present. What does the image of the flame tell us? Well, watch this video and find out. In that video, you saw the flame very tall for the first portion. Then, when you hit 3.2 inches is what it was, the flame became very small. This is because that's where resonance frequency was present. How the oscillations work and the pressure waves are such that as they come down the Reiki tube, they actually push the flame down and make it smaller. So we know when the flame is large, resonance frequency is not present. When the flame seems to be compressed, resonance frequency is present. In conclusion, we took these measurements to see how pressure, velocity, and heat release oscillations that can acoustically drive one another to create a combustor more favorable than a steady combustor, in the sense that there will be more heat present. If heat is added in phase with pressure oscillations, the Reiki tube will resonate. This was stated in the lab manual and proved in our experiment. Thank you for your time.